Good morning, all students. Today we discuss about the different type of semiconductors. There are two type of semiconductor. One is intrinsic semiconductor and other one is extrinsic semiconductor. First of all, we discuss about the intrinsic semiconductor. It is pure type of semiconductor in which only one atom take parts, or we can say that it is only one type of element, or there is, if we take the example of gallium arsenic, then it is one type of compound is there. In this pure semiconductor, when at low temperature, all the electron or the four electrons are bonded with neighboring atoms with covalent bond, means four electron or four valence electron by sharing it form the covalent bond. And at low temperature it behave like insulator, but when it get some energy from outside, then the electron jump from this bonded electron will jump and it get free, and this will generate the free electron in the semiconductor, due to which the current is conduct in the semiconductor. At the same time, there is hole also generated. So for the pure semiconductor, for intrinsic semiconductor, we can say that the number of electron is equal to number of hole. The number of electron created, it also created hole behind it. And according to the band theory, if we observe from the band theory, then it is conduction band and it is valence band. Then when the electron jump from the valence band to conduction band, then this is the free electron which take part in the conduction, and also there is a generation of a hole in the valence band. And the electron, when electron move from left to right in the semiconductor, at the same time the hole is also move from right to left in the semiconductor. Hole have positive charge, whereas electron have the negative charge. So this is the pure semiconductor. And when we dope the semiconductor with external material, then that becomes the extrinsic semiconductor. Now first, extrinsic semiconductor have two types. That one is N-type semiconductor and another is P-type semiconductor. So then first of all we talk about the N-type semiconductor. N-type semiconductor. The N-type semiconductor is doped with pentavalent impurity. Pentavalent impurity. Pentavalent impurity means the atom which have 5 electrons in their outermost orbit. That is, we can say phosphorus, nitrogen, and we can say arsenic, like that element. So this is the pentavalent impurity. When we dope with a pentavalent impurity, then in place of silicon, one pentavalent atom take. Pentavalent have 5 electrons in the outermost orbit. Then 4 electrons make the bond, but there is a 5th electron which not take part in the bond, and that is weakly attached with the phosphorus. So to become free, this bonded electron required more energy than the electron which is not bonded. So only getting a small energy, this becomes the free electron, and it will take part in the current of this semiconductor. So we can say that the number of electron is greater than number of hole in N-type semiconductor. And if you see the band theory for this semiconductor, then this is valence band and conduction band. Then there is a develop a donor level. This is donor level which contain electron. The 5th electron of phosphorus is in the donor level. So the electron jump from the valence band to conduction band require a high amount of energy, but the electron in the donor level easily can, with less amount of energy, it will jump to the conduction band and it not left hole behind it. So this is the N-type semiconductor. Now next is P-type semiconductor. Next is P-type semiconductor. So for P-type semiconductor, the doping are trivalent element, the element which have 3 electrons in their outermost orbit, like boron, aluminum, like element. And when we dope the trivalent, then what will do that trivalent, like aluminum, if we dope with aluminum, that aluminum have 3 electrons in their outermost orbit. Then only 3 electrons make the bond, but there is also a 4th place which left behind. This is not the hole, because hole is absence of electron from a neutral place where is there is a generation of positive charge. Means from a neutral place, if a electron is jump out, then there is a positivity is come. Means if this is a neutral place, if the electron is jump out from this place, then this becomes the positive, and there is absence of electron. This is known as hole. So this is not a hole because this is neutral. This is only a vacant space, and in this space, the electron which is bonded electron jump to this space. Then the place where this covalent, the electron participating in the covalent band, it is vacant, and this is known as hole. So this vacant space creates the hole. So for trivalent impurity, means in P-type semiconductor, we can see that the number of hole is greater than number of electron. And from the from the band gap theory, we can say that there is a level which created just above the valence band, which is known as acceptor, level, which is known as acceptor level, and it is very easy. From a electron is jumping from valence band to conduction band and creating a hole in valence band and creating an electron in conduction band. It required large energy than electron jumping to the acceptor level. If electron is jumped to the acceptor level, it will create a hole in the valence band, and the current is flow due to this hole, due to this acceptor. This is all about the P-type semiconductor. Thank you.